Hey, what's up, physics people? We have the fourth example from the unit on energy. This one deals with, sometimes if you're given a graph or if there's a energy type of thing happening and we have a force that is not constant. Like if you look at this graph, this is a force graph. And the amount of force being exerted is changing depending on, the position of the object that we're dealing with. So our standard type of, anytime you're asked about work, we have the equation, force times distance times cosine theta. Now that means that if you wanted to use that equation, you would have to have a constant force right there because you'd have to have like one number you could plug in. It's not always the case. Force isn't always constant. In which, this being an algebra-based course, the only way we can deal with that without the use of some calculus is a graph. All right, so we have this graph here, and I know that the work, if I have force times distance in an equation, well, I can get that from the area of a force distance graph. And oh my gosh, look at what we have here. It is a force versus distance graph. How gratuitous of a situation. All right, so we're going to go ahead and solve for that. So the question says, what is the work done from 1 to 4 meters? So right away at 1 meter, I want to draw a line down from my graph. And then at 4 meters, I want to draw a line down from my graph. And my goal now is, because I'm finding the area, because these two things right there are multiplied together, I just need to find the area under my curve on my graph. All right, so that is that whole area right in there. Now, there's two ways you could go about this, depending on how comfortable you are with areas and stuff. You could do this as the area of a trapezoid, or you could go and do this as a rectangle with a triangle on top. Either one should get you the exact same answer. I don't care what you do. I am going to do a trapezoid because then we only have to use one formula rather than two. And I am lazy like that. All right, so this is like a trapezoid that kind of fell on its head, or on its side. All right, so this side right here, that has a height of 15. And then over here, for my 4, that goes all the way to 30. All right? And so when I do the area of a trapezoid, that is 1/2 base 1 plus base 2, so the two sides that have different lengths, times the height. So we just got to plug in our values now. I got 1/2. The first base right here is 15. So 15 newtons. Plus here I have 30 newtons. And the height, the thing between those, it goes from 1 meter to 4 meters. So that is only 3 meters long. All right. So once I calculate all that stuff out, 45 times 3 times 1/2, that gives us 135 over 2. Or as all the kids say, 67.5 Newton meters. All right, so the amount of work done by this force is 67.5 Newton meters, or we could call it 67.5 joules. All right, they are the exact same thing. All right, ladies and gentlemen, questions, comments, any other videos you want me to make, I don't care. Leave them in the comments if you feel like it. Otherwise, I'll see you in class. Y'all have a good day.